An invisible weight presses on your chest. You stare at the screen, paralyzed, while a predictable chemical sequence hijacks your motivation. When you choose the instant gratification of a digital distraction over effort, you disrupt your brain's pleasure-pain balance. You get a sudden spike of dopamine from the screen. Inside that trough, the project you were avoiding doesn't simply feel difficult. Your brain lacks the neurochemical fuel to even initiate it. Your brain operates as a predictive machine. It runs a subconscious reinforcement learning algorithm, constantly weighing the effort required to complete a task against the potential reward. These fMRI scans show the dorsomedial prefrontal cortex, the area tracking effort. Researchers found the brain miscalculates this equation, steeply discounting future rewards. The scatter plot on the right correlates these neural time preferences with actual procrastination. Simultaneously, the brain exaggerates the immediate pain of starting a task, skewing the math against taking action today. Procrastination is a literal computational glitch in your brain's value approximation system. Because we know how the algorithm works, we can patch the glitch using a 4-step behavioral protocol. Step 1 is reset the baseline. When you are stuck in an unmotivated, dopamine-depleted state, you need an immediate biological exit strategy. Waiting for motivation to return is ineffective. You have to actively choose to do something significantly harder and more uncomfortable than your current state of doing nothing. The micro-habit here is a deliberate 10-minute dopamine fast. Put the phone away and sit in total silence. Or expose yourself to safe, acute discomfort, like a cold shower. Introducing discomfort steepens the trough, forcing your dopamine levels to rebound faster. Step 2 is map the loop. Putting things off is an automatic response. It is a sequence of memories hardwired deep in your basal ganglia as behavioral chunks. According to Charles Duhigg, these habits run on a strict cycle: a cue, a routine, and a reward. Procrastination occurs right here at the routine step. To break the cycle, you must identify the invisible trigger kicking it off. Grab a pen and write down exactly what triggers your urge to delay. It might be opening a blank document or seeing a specific email. Naming the cue physically strips the habit of its subconscious power, pausing the algorithm so you can insert a new response. Step 3 is revalue the effort. Your brain's reinforcement algorithm is vastly overestimating the energy required to begin. You have to manually scale the task down to trick your threat detection system. This template outlines B.J. Fogg's Tiny Habits methodology. You take an existing daily routine, your anchor moment, and attach a ridiculously small new behavior. Moving right, we find the celebration step. Generating positive emotion right after the behavior releases dopamine, chemically wiring the new routine. Apply the 2-minute rule. Make your next action absurdly small. Write a single sentence. Read 1 paragraph. You bypass the brain's effort alarm entirely and get dopamine flowing in the right direction. Step 4 is lock in the identity. The urge to delay tasks is heavily influenced by your genetic makeup. Research into the TH genotype shows that variations in your genes dictate your baseline dopamine levels. This genetic difference directly affects how easily your working memory lets in distractions. The final micro-habit overrides this predisposition. Every night, write down 1 sentence. I am someone who starts before I feel ready. You shift the psychological framing from fighting a bad habit to becoming a new type of person. Combined, these 4 steps override genetic predispositions and acquired behavioral loops, updating how your brain calculates the value of starting a task. This 4-step framework replaces vague motivation advice with concrete biological rewiring. You no longer have to sit helpless in a chemical crash. You now have algorithmic control over your own neurochemistry. Applying this science turns a vague struggle for willpower into a manageable set of biological inputs.